Hi, this is your Lucky sir. Welcome back to Chemical Kinetics class 2. So in this class we'll go with rate of reaction, factors affecting rate of reaction. One very important for all your board examination. This is one important question also. For your board examination, generally the students will be getting this question. Collision theory, rate of reaction, factors affecting rate of reaction. So based on the velocities, reactions are classified as follows. Okay, now one is very fast reactions. Very fast reaction means with what speed they are happening and all that you can check. Ionic reactions will be very fast reactions. Very fast means they will be completed within no time. Okay, now in your laboratory you are doing now, all those are ionic reactions. You will be simply adding some compound, immediately product is formed, precipitate is formed, immediately gas is coming out. Those reactions are called very fast reactions, or you can call them as instantaneous reactions. Okay, now we have no interest in this because they are very fast. Chemical kinetics is not related to with this. Reactions with measurable speeds, that means 5 minutes, 10 minutes, 1 day, 2 days, like that. Okay, now esterification is one example. Ester hydrolysis is another example. Photosynthesis process is one more example. Digestion of food is for fats. Curding of milk for fats. All these measurable speeds. And reaction with very slow rusting of iron. Okay, now iron rust formation will take lot time, but these are also not of our interest. We don't have much interest in these kind of reactions because we don't have that much time. Okay, so not at all worry about very slow reactions and very fast reactions. We need measurable speed reactions. See, rusting of iron is one example here mentioned. This is not our interest. So coming to this H2 plus O2, formation of water is also not easy. Okay, it takes a lot of time. H2 and hydrogen oxygen joining and to form water is not a very simple reaction. Okay, uncatalyzed reaction mentioned. So the rate of reaction depends on what factors. One is the nature of reactants. Nature of reactant, as we were discussing, if ionic reactions are there, they are very fast. Covalent reactions are there, they are slow. Ionic fast, covalent will be slow, right? Why covalent reactions are slow? Because we need to break the bonds, we need to make the bonds. For that purpose it is going to be fast. Okay, now covalent reactions will be slow. Ionic reactions, no such nonsense points, so directly ions are there, that reactions will be very fast. Covalent reactions are slow, that is mentioned here. You can see ionic substances in aqueous solution contain free ions, so ions can directly participate in reactions as bonds need not to be broken. That's why ionic reactions are very fast, or you can say instantaneous reactions. Laboratory reactions are most of the reactions are ionic reactions. You are getting those reactions very fast. Examples: reaction between silver nitrate. Silver nitrate is AgNO3. Potassium chloride is KCl, gives rise to AgCl. Formation of silver chloride precipitation happens within no time. Neutralization reactions like H2SO4, NaOH. This is neutralization reaction, gives you Na2SO4 plus H2O. All neutralization reactions are going to be very fast reactions. Reactions between covalent substances are slow because in such reactions breaking of old bonds and formation of new covalent bonds occurs. And if the number of bonds are more to break and number of bonds more to form, those reactions are however slow reactions. Okay, so let's come to that point. Reaction between potassium permanganate and oxalic acid. Do you remember this reaction? Potassium permanganate 2KMnO4 plus 5H2C2O4. If I am not wrong, 3H2SO4 gives K2SO4, 2MnSO4, 10CO2 and 8H2. So many bonds to break. That's why these reactions are generally slow reactions. Digestion of food, photosynthesis, fermentation of sugar, many organic reactions, these are generally slow reactions. Because these reactions are covalent reactions, we need to break the bonds, we need to make the bonds. Then coming to concentration. With an increase in the concentration of the reactants, rate of reaction generally increases except zero order reactions. Zero order reactions don't depend on the concentration, but remaining all, if you are increasing the concentration, rate of reaction also increases. According to law of mass action, rate is equal to K into concentration of reactants, or you say rate is proportional to concentration and rate is equal to concentration into A. And generally we mention here some power. This power is known as order. About order we'll discuss in detail later. This topic, 50% of this topic contains order things only. Okay, now we'll order about order later. Okay. So rate constant or specific rate is K here. K is rate constant, or you can say specific rate. About this we'll discuss more in order case. Then coming to temperature. Temperature, generally with an increase in the temperature, reaction increases. Okay, now this may be endothermic reaction or that may be exothermic reaction, but the rate of reaction generally increases with temperature. Okay, because the rule is, or the condition is, or the factor is, actually endothermic or exothermic, the graph will be like this. This is exothermic graph, this is endothermic graph. Whatever it is, they need to reach a particular state called excited state. Okay, now, and this transition state or activated state can be achieved only when it contains particular amount of energy, and that energy can be attained by accepting some temperature. So when you are increasing temperature, temperature increases the velocity, velocity increases the kinetic energy. When kinetic energy increases, they can reach this transition state and they can be converted into products. So that may be exothermic or endothermic, temperature always favors. Presence of a catalyst or inhibitor. Inhibitor means makes it slow. Catalyst means generally makes it fast. So in such kind of cases, what happens? For example, KClO3. KClO3 decomposition is very slow. But when you are adding MnO2, the reaction is very fast. Okay, now remember this reaction. This is also very important. 2KClO3 gives rise to 2KCl plus 3O2. This reaction is slow. But if you add MnO2, that reaction will become fast. H2 plus R4 gives rise to water. As we discussed just now, water formation is very, very, very tough. Okay, not easy, but it is catalyzed by platinum. A catalyst increases the rate of reaction by carrying the rate of the reaction in a new way. For example, a reaction is like this, and with the catalyst it is like this. Say simple words, man. Okay, now this is you, and you want to become an doctor or engineer, you want to write NEET exam or JEE exam, for example. So you need to qualify this exam, passed. So this examination purpose you need to prepare. What happens is, if this blue line or this green line, what I am showing, is without coaching, okay, without a teacher help, you can say, okay, that may be individual teaching, individual coaching, or tuition, or a coaching center, or a college, whatever it is. With this, without that means you don't know what to read. You will be studying all parts of the textbook, and you may not be getting right score. But when you are going to a coaching center, now this red line, that means your teacher knows which part is to be more focused. So your teacher is like a catalyst. He makes you utilize the time properly and avoiding the unwanted material, unwanted questions, unwanted topics which are not at all useful for your JEE or NEET examination, whatever it is, whatever the exam you are going to write. So the advantage of joining a coaching center, the advantage of taking tuition is they function like catalysts. They will make you with less efforts in less time to crack the exam. Okay, now, so this is your catalyst. So your sirs are your catalyst. If you are preparing on your own, it is like that means you can get. I am not saying that without teacher you can't get. You can get, but the problem is you need more time, you need more concentration, you need more efforts. But if you are going to a teacher, he will guide you in the right way in sooner time with less efforts. Okay, now, so your teacher is a catalyst. So catalyst always increases the rate of reaction by carrying the reaction a new path involving lower activation energy, right? So catalyst alters rate of reaction, definitely. Path of reaction changes path of reaction. Activation energy will be decreased, and activation time is also, and rate constant. Okay, now this is definitely done. Catalyst job. But catalyst is not at all related to delta G of reaction, or delta H of reaction, or delta S of reaction. All these you studied in your first year. Delta G is Gibbs energy, or you say free energy. Delta H is Enthalpy of the reaction, delta S is entropy of the reaction. Entropy or enthalpy or initial energies, all these are not changed by the catalyst. Catalyst has no relation with any of this. Okay, now any of these are not affected by the catalyst. Catalyst has no effect on all this. Okay, now, and very interesting thing is, if a forward reaction is catalyzed, it means backward reaction is also catalyzed. Okay, now that means when, for example, A gives rise to B, if this is a reversible change, more B formed means definitely backward reaction is also catalyzed, because when more B is there, reverse reaction is also possible. So A to B, B to A. That means a catalyst increases both forward as well as backward reactions. Then we'll meet in class 3 next. Thank you.